If you're watching this video because you're gone today, please make sure to write down these perfect squares. That will be helpful as we break down square roots later on. On your calculator right now, if you were in class with me, please go ahead and let's just take very simple. Let's take like the square root of, let me pick one of these numbers, the square root of 9. Very simple. How do we do that? We are going to hit the blue button. We're going to go straight down to where we see x squared. That is our square root. I'm going to zoom in so people at home can see this. I type in square root of 9, and obviously we get an answer of 3. That's simple enough. Now, let's take the square root of negative 9. And we already know when we take the square root of a negative, it is going to say error. It's not possible. We have learned this dating back to middle school or maybe even in 9th grade. We cannot take the square root of a negative number. It does not produce a real answer. And real answers are generated on a calculator. Real answers are graphed on what we call a Cartesian plane with an XY axis. This does not produce it. It doesn't mean we can't evaluate it, and we're going to learn about that today, but it doesn't produce a real answer. And that's all you've worked with to this point is real answers. Real answers are anything like pi, for instance. Pi is a real answer. Even though it's not pretty, it's irrational, it's still real. So how do we actually then go ahead and evaluate something when it has a negative inside? So let's start again with the square root of negative 9. Today we're going to learn about imaginary numbers. Imaginary numbers are a part of a new number called a complex number. A complex number. And a complex number has two portions to it. It has a real portion and it has an imaginary portion. And together it makes a complex number. It's kind of like on social media when there used to be the status where maybe 10 years ago and you'd say your relationship status and somebody would put it's confusing, it's complicated, right? There's like many facets to it. So complex, there's many parts to it. There's a real part and an imaginary part. And together it creates a complex number. Whenever we see a number from now on that contains an I, we know it's a type of a complex number. So let's figure out how do we actually evaluate these. If I asked you to take the square root of negative 9, what your math teacher previously told you was not wrong. You cannot, in this form, take the square root of a negative number. So what we do is we get sneaky here. We need to sneak this outside of the square root. And when it comes outside, it sneaks outside and it does not become a negative. It becomes an I. Now, the square root of 9 I can evaluate. I know this alone evaluates to give me 3. And I3 is not wrong, but it's kind of like if you wrote down a question on your paper, but you did not end that question with a question mark. You put a period instead. So it's not proper. We could understand what you were asking, but it's not proper. This is not mathematically wrong. We generally put our number first, and it's followed by the I symbol. Okay. All right, so we are going to move on right now to what does this look like? This is called an expression. There's no equal sign. There's no variable. You're bringing it back later, right? Okay. Please write down x squared equals negative 16. X squared equals negative 16. So how do we go about solving this? I want to remind you, when we are solving equations, a lot of students, and in fact, I would say the vast majority, you're so used to using PEMDAS. You're like, yeah, I've learned about PEMDAS. PEMDAS helps me when I'm going to solve. Well, actually, if I gave you this just really quickly, if I gave you an expression, you'd use PEMDAS. You'd use PEMDAS. But when you're solving and you're trying to solve for a variable, we go PEMDAS backwards. When you're solving, you do PEMDAS backwards. Let me demonstrate. So on this side, there is no adding or subtracting I need to remove. There is no multiplying or dividing, but there's an exponent. To remove the exponent, I do the opposite operation. Opposite of squaring is square roots. This will produce two answers. But again, like I said, your previous math teacher told you the truth. You cannot take the square root of a negative. So this pops out front and it becomes not a negative, but an I. And now I can take the square root of 16. The square root of 16 is 4. If you gave this to me on an assessment, I would not count it wrong, but the proper way to write it would be plus or minus 4i. Why is there a plus or minus? Because we have two answers represented here. That's a great opportunity for me to come back here and show you this. This is an expression. This is an expression. This is an equation. An expression, evaluate that for me. What is the one answer? What's the square root of 25? 5. This has one answer. You evaluated it. But this is an equation. And this equation has two answers. It has plus or minus 5. Okay, let's jump to the next one. Make sure you have paper out. Please put these away for me. Thank you, Christian. Okay, let's start with negative 2x squared. Let's go negative 2x squared. I got to think here. I want to do this. Let's go minus 2. And let's go minus, let's go, I got to think how I want to do this here. Let's go plus 70. So I'm going to write this PEMDAS here again. Please excuse my dear Aunt Sally. Whenever we are solving an equation, we are going to reverse the steps here. Reverse the steps. So the very first thing that we are going to do is to get x by itself, I ask myself, is there adding or subtracting on the side that contains the variable? And there is. Now, how do I know what to start with? Well, we are going to get rid of whatever is being added or subtracted. That would be this portion. Opposite of subtracting is adding. And I bring down the negative 2x squared equals 72. Now, on the side that contains the variable, is there multiplying or dividing that I need to remove? And there is. Opposite of multiplying is dividing. 72 divided by negative 2 is negative 36. If you need to use the calculator to come up with these operations, then do so. And now, exponents. To remove this exponent, I'm going to take the square root. This tells me I'm going to have two answers. How do I represent those? With a plus or minus. Can I take the square root of a negative 36 in that form? The answer is no. What do I need to do first? I need to move the negative out front to become an I. And now I know the square root of 36 is 6, and I'm going to put it in proper form. Okay, turn to your partner to make sure you get this. Katie, just I have no idea why I put a 3. Did I say 3 or did I say 6? Okay. This is what happens when you get old, Katie. All right, here's the next one. Thank you, Katie, for finding that mistake. So you may not get to two problems, and that is just fine. Here's our next one. Let's go with 3x squared. 3x squared plus 5x. And let's have this be a negative 22. I'd like you to try this the entire time. I'm even going to make a deal with you. So in this problem, please excuse my dear Aunt Sally, I am going to start by getting rid of adding or subtracting the side that contains the variable. Subtract 5 from both sides. 3x squared equals negative 27. Multiply and divide it. I'm going to divide by 3. X squared equals negative 9. I'm going to remove the exponent by square rooting. But I can't take the square root of a negative. So what I'm going to do is I'm going to recognize both answers. The negative sign comes up front and becomes an I. And the square root of 9 is 3. Now whether you put 3i or I3, I'd accept both, but this is in proper form. Subtract 12 from both sides. Divide by 5, negative 5, excuse me. Take the square root. I have two answers. I can't take the square root of a negative, and the square root of 25 is 5. So I'm going to write this in not proper form. I would definitely accept this as well, but proper form is going to have the number first followed by the I symbol. Let me first read this out loud. We're going to apply it, and then we'll come back to i's. What I definitely want you to have down in your papers is that I squared equals negative 1. So rules of expressions with negatives. You're going to count the number of negatives, and if it's an even number, 2, 4, 6, 8, so on, your final answer is positive. When you count the number of negatives, if there's 1 negative, 3, 5, 7, so on, your final answer is negative. So if I gave this to you, and I said, can you please evaluate this? Here's what I would do to try to be quick. I'd go, okay, let's first work on the number of negatives. There's 1, 2, 3, 4, 5. There's 5 negatives. An odd number of negatives produces a what type of answer? A negative answer. And then I'd go 2 times 3 is 6, 6 times 1 is 6, 6 times 2 is 12, 12 times 1 times 1 times 1 is still 12, and there is a total of 3x's, x cubed. That's how I would evaluate it. Let's apply that same basic concept to i's. Remember, i's come in groups of 2. This must be done on your paper, what I have my finger circling right now. This must be done on your paper. I's are always going to congregate in groups of 2. So if I write down I to the 6th power, I'm going to start by doing this the long way. I'm going to write down 6 i's, but as I write them down, I'm already going to group them into groups of 2. 2, 4, 6. I times I is I squared. We've already learned about exponents. So I squared, I squared, I squared. You can pull up right next to Christian on another side of Roberto. Okay? I squared, and I squared gives you I to the 6th. This is all good. And remember, I squared is always equivalent to negative 1. So down here, I'm going to change this into negative 1 times negative 1 times negative 1. Okay, how many negatives do I have? I have a total of 3. 3 is an odd number. My final answer is negative, and 1 times 1 times 1 is negative 1. So I to the 6 is equivalent to negative 1. Okay, check with your partner to make sure you understand before we try larger numbers. Check with your partner. We're going to do I to the 9th next. So I'm going to write down 9 i's, but as I write them down, I'm going to group them into groups of 2. There's 2, 4, 6, 8. Oh, and this last one has no friends. It's all by itself. It's a lonely I. I can't attach another I, otherwise it would give me I to the 10th. I'm only provided with I to the 9th, and I'm asked to evaluate it. This group is equivalent to I squared. What's I squared equal to? Negative 1. This group is equivalent to I squared, and I squared. I have 4 negatives. That's an even number of negatives, which produces a positive answer. 1 times 1 times 1 times 1 is 1, and don't forget about the lonely I. How do I evaluate this? I would start by writing down 7. 1, 2, 3, 4, 5, 6, 7. And if you forget to group them into pairs of 2, there's 1 pair, 2 pairs, and 3 pairs. Each of these pairs is the same as I squared. Is the same as I squared. What is I squared equivalent to? So I have an odd number of negatives. And if you forget that fact, you can go, what's negative 1 times negative 1 times negative 1. But an odd number of negative produces a negative answer. 1 times 1 times 1 is 1. But we have this lonely I. Don't forget about the lonely I. Anytime your number is odd, you're going to have a lonely I. Whether it's 3, 5, 7, 9, and so on. Okay? Now, I'm going to go through here, and I'm going to see you can continue to do it this way, but I'm going to try to teach you right now a little bit faster way. I'm going to count by 2s. You're going to count on your fingers. Okay, ready? Everybody get your fingers ready. Here we go. 2, I'm going to go up to 14. 2, 4, 6, 8, 10, 12, 14. How many groups of 2 do I have? How many pairs? 7. 7 is an odd number. What do odd numbers produce? This is negative 1. Is there a lonely I? No, because it's not odd. That problem's done. Okay, watch this. Ready? You don't have to do it this way. You can draw them out. I'm just giving you different ways of doing it. Let's go right now to 19. 2, 4, 6, 8, 10, 12, 14, 16, 18. I can't go up or I'd go past it. So I have 9 groups. 9 is a odd number. So my final answer is negative. But because it's odd, I have a lonely I. Using that fact, unless your partner is like, that, Miss Bradley, you just made that confusing. I want to draw them out, then do that. I want you to do 2 more. So I'm going to do by counting by twos. I have 2, 4. I can't go to 6. I have to go over. So I have two groups. If you're a visual learner like I am, there's up to 4. And then we have this lonely 5. So I have two groups of 2 pairs. That's an even number. Even produces what? A positive. So I have positive 1 and a lonely I. I'm going to count to 16. 2, 4, 6, 8, 10, 12, 14, 16. I have 8. 8 is even. I have another positive 1. And it's not odd, so there's not a lonely I behind it. I gave you this problem as an 8th or 9th grader, and I just said, can you go ahead and simplify? You would think to yourself, 3 plus 4x plus negative 5 plus 6x. And then you would circle. Okay, there are different signs. So you subtract or you pull out your calculator if you needed to. Different times, subtract, keep the sign of the larger number. Then you'd recognize these are like terms, and you'd say 4x is positive, 6x is positive, so the same sign, add, keep the sign of the larger number, and you'd be done. Give me a thumbs up or thumbs down if you understood that concept. Okay, there's no difference. Now I'm going to take this. Please do not write this down. And I'm going to do 3 plus 4i and negative 5 plus 6i. Exact same concept, but this is a complex number. A complex number has a real portion and an imaginary. Real portion and imaginary. So exact same thing. 3 plus 4i minus 5, minus 5 plus 6i. 3 and negative 5 combined to give you negative 2. A positive 4i and a positive 6i gives you a positive 10i. It is no different than if I had, please don't talk when I'm talking, if I had an x or I had an I. You combine just the same way in terms of adding or subtracting. That being said, here's your next problem. When this is positive, you may be able just to look and combine. When this is positive, 11 plus 7 is 18. 13 plus a negative 20. Well, 13 plus a negative 20, they're different signs. I have to subtract, and then I keep the sign of the larger number. Did anybody get the first problem correct? Hands up high? About 50%, okay? Now, it's going to change when this is negative, but we're not there yet. 21 plus 12. 21 plus 12 is 33. Am I correct? And negative 5i plus a negative 7i, well, they're the same sign, so I'll combine them and keep the sign of the larger number. Now, this changes when we have a negative. Put your pencil or pen down for me, please. Pencil and pen down. Raise your hand if you have an idea what I need to do before I do the exact same. Okay, Luis, your hand went up first. What do you think I need to do? Yep, we're going to change the symbol. So what I believe he's trying to say is we need to distribute this to whatever's behind it, and in doing so, we change the symbols. If everybody heard that. What I saw yesterday is there was confusion, so that's why I pointed it out. Some people thought I needed to change the symbols of what's in front. It is what's behind it. So when I write this out, it's 4 minus 6i. This was positive, now it becomes negative. This was negative, now it becomes positive. And then I do the exact same thing. 4 and negative 7, when I combine them, I get a negative 3. Negative 6 and positive 11, they're different signs. Subtract, keep the sign of the larger number. Can I have a thumbs up or a thumbs down if you understood the concept? Okay, we don't have enough people. We'll do more problems. Okay, you ready? So here we go. With your partner, let's have you start with just one of these. 13 minus 9i, subtract negative 8 plus 3i. With your partner, begin. All right, you ready? So I'm going to distribute this and also distribute this. So I have 13 minus 9i plus 8 minus 3i. When I combine like terms, I always want to do the real portion first. That means it contains no I. 13 plus 8 is 21. And combining like terms, a negative 9i and a negative 3i is a negative 12i. So what we've done so far that you will have to demonstrate on a quiz is, if I give you this, are you ready? Let's see how fast you can work. Ready, get set, and go. Evaluate with your partner. See if you can do this in 30 seconds or less. Go. 1, 2. I would do it like I've seen Christian and Antonio doing it. I would do it like I've seen a Christian. You do it however you want. So maybe you want to count by groups of 2. 2, 4, 6, 8, 10, 12, 14. Oh, I got one left over because it's negative. I have 7. So I have 7 groups. 7 is an odd number. An odd number of negatives produces a negative number, but there's this lonely I because it is an odd number that was left over. It was not in a pair. Okay, so this is one concept you have to demonstrate to me today. Here's another concept. Can you add correctly? Another concept. Can you subtract correctly? Now we're going to flip to the back side. I'm flipping to the back side. You don't have to, sorry. What is I squared equal to? Tell me. What's I squared equal to? Okay, please put your pencil or pen down and watch this first problem. It may confuse you. I am not being asked to add or subtract. When you have 2 parentheses that are pushed together, what operation is it asking you to do? And when you multiply, you are going to FOIL. Now, the only difference is we are now adding this concept that I squared equals -1. So please watch me right now. Not everybody has mastered FOILing. I'm going to start with the front. 2 times 4, and by the way, for those that sometimes struggle, you're going to put down 4 lines. 2 times 4 for the front is 8. Now the outside, 2 times +7 is 14, and there's an I. The inside, -3 times 4 is -12, and there's an I. Now here's where it's tricky. -3 times 7 is -21, but how many I's are there? What is 2 I's? What does I times I give you? So I have -21, but then I have an I squared. Now, here's where I'm going to be lazy. I'm going to come just underneath, and I'm going to write -21, and I know I squared is equivalent to -1. What is -21 times -1? Okay, I'm just being lazy. +21. Now it goes back to exactly what we did right here, when I have 4 things written out, and I just have to combine like terms. So now we're going to do this. I have 4 terms. I'm going to start with the reals, the ones that don't have I's. They're the same sign, so I add to get 29. They're different signs, so I subtract to get 2, and I keep the sign of the larger number. You're doing the next problem with me. Please write it down. If you understand this concept through lots of practice, you will understand the very last concept of today. So let's practice this a few more times. 5 plus 3i, 2 minus 6i. Make 4 lines. Eventually, when you're doing this on your own, you don't have to, but let's do this to make the least amount of mistakes. I'm going to put FOIL off to the side. You don't have to. So I'm going to start with the front. Okay. 5 times 2. Thank you. 10. I'm going to do the outside. Now, here's where kids make a mistake. They forget about the negative. What's 5 times -6? -30. And what else do I have to remember? An I. 3 times 2. And there's a I. The last one. 3 times -6. -18, and there's 2i, so I squared. -18i squared. I'm going to go below, and I'm going to write -18, and I'm going to transition I squared into a -1, and I recognize that -18 times -1 is a +18. If speed is not a factor, just a basic understanding, and 1 through 5 and understanding not on speed. Give me a 1 through 5, please, at this time. Don't keep your hands on 1 through 5. It's okay to be a 1. Okay, are you ready? This is not a speed one. Let's just see what you can do. This first one's going to be with your partner. The second one later on will be by yourself. So this is with your partner. front, outside, inside, ooh, and last. Now, this is 32 times negative 1. 32 times negative 1 is a negative 32. Let's combine the reals. They're different signs, subtract. Keep the sign of the larger number. Ooh, I went back, and you go down one more. And they're the same sign, combine. And this is what I have. Who has negative 26 plus 28i? Negative 26 plus 28i. See how we can do this. Then we're going to move on to our last learning objective, which is division. I'm going to do the fronts to get 14. The outside is negative 14i. The inside is negative 6i. And be careful, a negative times a negative is a positive. Positive 6i squared. If you could hold up with talking, please. 6 times negative 1 is negative 6. It's very easy to make small mathematical mistakes here. These combine to give us 8. Put the real down first. This is called the imaginary portion. Same sign, I'm going to combine. And if you need to use your calculator to come up with those basic mathematical operations, feel free to do so. All right, so this is what I have. This is called the complex number. This is the real. This is the imaginary. We're moving into our last operation. Our last operation is division. All right, are you ready? Please write this down. Here's our first one. So our first division problem, 5 plus I over I. Now here's what you need to learn. You need to learn that in your final answer, you can never have I in the denominator. So how do we remove I? How do we remove I from the denominator? Well, in this case, when there's only an I in the bottom, it could be a number like 2I, but when there's only an I, it's not like 2 plus I or 3 minus I. Just an I, and there could be a value in front of it. If we multiply by I, and whatever we multiply times the bottom, we have to multiply times the top to keep this original fraction the same. I would definitely be writing this down right now. This will help you for your homework. If we multiply the top and the bottom by the same quantity, it will not change the value of the original fraction. Why would I do that? Because now how many i's do I have in the bottom? I have I squared. There's 2 i's. I squared when I multiply. On top, I'm going to distribute this to get 5 times I plus I times I. Now, a mistake I've seen students make is, well, can't you just cancel these out? You cannot cancel out in the numerator and the denominator if they're separated by addition or subtraction. So I'm going to rewrite this. I know that I squared is equal to negative 1. So I'm just going to rewrite this right now. I have 5I plus negative 1 minus 1 over negative 1. And I'm going to put the real portion first. So the real portion is the part of the complex number that has no I. So I have a negative 1 and a positive 5I over negative 1. If you want to leave it like this, that's adequate for me. Otherwise, we could divide each one of these by negative 1. Negative 1 divided by negative 1 is positive 1. And 5 divided by negative 1 is negative 5I. This is equivalent to this. It no longer has an I in the bottom, and that's what my goal was. Your next problem, you are going to do this one with your partner. Please write this down. Please write down 3 minus I over 2I. 3 minus I over 2I. Now, when you multiply, because we only have an I, and there can be a number in front, you're going to multiply the top and the bottom by I, and then simplify. You have, this would be tricky. Let's try. So I'm going to take the top and the bottom by I. So I have 2I squared. And now I'm going to go reverse as I distribute. So I have 3 times I minus I times I. Okay, well, let's see what we can do here. I have 3I. Now I know that I squared is negative 1. And I know I squared in the bottom is negative 1. Replace and replace. Now 2 negatives make a positive. So I have 3I plus 1 over negative 2. None of this would be wrong, but they do want us to put it in a form where the real portion goes first. So I'm going to put the positive 1 first, the positive 3I over negative 2. Now, you can leave it like this, or again, like we showed up above, you may want to share this with both. If you are going to separate it, it has to be shared with both. So I have 1 over negative 2 plus 3i over negative 2. Either one of these would be fine. I have a real portion and I have an imaginary portion of a complex number. I said to you, give me 1 second here, what is the conjugate of this? Don't write this down, just watch. The conjugate of 5 plus 2i would be 5 minus 2i. The conjugate of 3 minus 5i would be 3 plus 5i. Do you guys see that? The only difference is you're changing the symbol in between. That's it. So here's our next problem. We are going to go with 3 plus 2i over 5 minus 1i. So this looks much different than the two previous problems, electronics way. This looks much different than the two previous problems that we have done. Okay, I thought you were on your phone. Okay, so what we are going to do right now is we are going to multiply by the conjugate of the denominator. Why are we doing that? Because our goal is not to have an I left in the denominator. So whatever I multiply by the bottom, I must multiply by the top. And you're going to see that by multiplying by the conjugate of the denominator. Remember, conjugate means the exact same, but we switch the symbol in between. If I multiply by the conjugate of the denominator, in doing so, I no longer will have an I in the bottom. And we're going to see that in just a second. Now, why am I also multiplying by the top? I want to keep the value of this original fraction the same. As long as I multiply the top and the bottom by the same amount, well, that's really equivalent to 1. So I'm not changing the value of this fraction. Okay, so let's put parentheses in parentheses, please. This is a little more work, but it's not any harder. Now, here's a shortcut. Please put a big arrow to the denominators. When you are multiplying conjugates, you only have to do the F and the L. The O and the I every single time will be additive inverses. That means they'll be directly opposite of one another. Like in this case, we'd have one would be 5i and one would be negative 5i. Every single time, think of them as wiping themselves out. When you're multiplying conjugates, you only have to do the F and the L. Now on top, these are not conjugates. Why? They're not exactly the same with the sign in between different. So here we go. I'm going to do this bottom part. I'm going to do the F. 5 times 5 is 25. Now I'm going to do the L. Negative 1 times 1 is negative 1, but then I have two i's, I squared. So I'm going to replace the I squared with a negative 1, and I know negative 1 times negative 1 is a positive 1. I already know that when I now take and multiply these conjugates for this particular expression, I end up with 26. 26 is in the denominator. Okay, now we're going to do the numerator just like we've done problems before. So if you want to think of it, just cover this up. And I'm going to do F-O-I-L. F-O-I-L, okay? So I'm going to multiply the fronts. I'm going to do this off the side. Multiply the front to get 15. Multiply the outside to get a positive 3i. Multiply the inside to end up with a positive 10i. Now multiply the last to get a positive 2i squared. So I have 15 plus 3i plus 10i. And oh, I got to go over here and do the math. I know that I squared is equivalent to negative 1. And 2 times negative 1 is the same as negative 2. So let's go ahead and let's combine here. 15 is like terms with negative 2. That gives me 13. 3 and 10 are like terms to give me 13i. If you wanted to separate without reducing, it would look like this. If you wanted to separate into the real and the imaginary part of the complex number, that'd be fine. Otherwise, I'm okay at this point leaving it in this form.